Hello, there is Zmotion Technology. Let's continue XPCIE1032H control card learning. Today, Lesson 7, How to Achieve PSO and Position Latch Functions. In this video, functions-related introduction, commands, and one routine will be shown. At the same time, when you want to know details of this lesson involved other information, like how to add C# library file, how to connect, how to use RTSys, and so on. You could review corresponding former lessons, videos or articles, Lesson 1 to Lesson 6. Let's begin. Not all Zmotion motion controllers support PSO and position latch function. But the XPCIE1032H card supports both. It can be known it has 16 digital inputs and 16 digital outputs. Among them, there are 8 high-speed inputs and 16 high-speed outputs. Then, in 0, 2 and 3 support position latch. Out 0 to out 15 support PSO function. Therefore, in real applications, they can be used to achieve high-speed stable actions. For example, use in 0, 2 and 3 to do position latching. Use out 0 to do PSO, fly shooting. Here is the wiring reference. Okay, so what is PSO? Full name is Position Synchronized Output. Specifically, use specialized command to set comparison mode. Compare captured MPOS with the position that has already been set. Then, like this, make it output at high speed and stably. In C#, this command is mainly for PSO. 5 parameters are needed. The important one is the third one mode. There are 6 modes in total. Set it according to real application. Through it, the motion will be stable, fast, and accurate enough. Check this graphic. Left one is without PSO. The right one uses PSO. Obviously, in corner deceleration, it outputs stably. In whole trajectory, they are with equal space. Then, if in real dispensing, it can avoid overglue, glue breaking, etc. And the corner motion just occupies one small part. When it can be processed rapidly and stably, the whole production capacity is increased. What is latch function? It is easier, basically, used to record feedback position. Same, use the command to set modes. Set in as latch in. Then trigger it to read data. The value will be saved into the register immediately. Please note, it only records the latest data. This command. Also, set modes through the parameter a mode. There are 21 modes. Here only shows 4. If one is set, in will be triggered to start recording when in rising edge of Z-pulse. Recorded absolute position value is saved into register. As usual, Zmotion has already written one routine. Use in 0 and out 0. This is the hardware wiring. Then, to code editing. Related PSO and latch commands are here. They all are used. For PSO, update parameters at first. Clear former configurations. Then, use HW timer command to set hardware timer. Next, set comparison positions. Select PSO modes to run it. For latching, you only need to select axis type. Set required modes, open time, then trigger it. After coding, this is the UI. Full codes, you can contact us. Let's enter C# to check it clearly and run it for you. It can be seen there are 4 parts. Connect to your card. Check now motion state and motion distance. PSO and encoder latch. These two can be known in former lessons. See PSO here. The first step, open PSO. Click this to open it. The second step, select needed comparison modes. Here, Mode 1, compare single point. The third step, fill in corresponding parameters of PSO modes. We use out 0 to do PSO. Select 0 for parameter 1. Parameter 2, the starting point output state. That is, output high level or low level for the first comparison output. 1 is set, which means high level. Parameter 3 and 4, the starting point and the end point of comparison. For example, out 0 to out 3. The first one is out 0. the last one is out 3. Parameter 5, the direction. Forward or reverse. 1 indicates forward direction. Therefore, at the same time, please set comparison point in advance. Add or delete any row. Enter distance. Now, 4 points are set. When it is at 50, trigger PSO. When at 100, invert it. Same, 150, 200. PSO parameters are configured. Then, whether to open the timer to invert the output. Now, mode 1, no need it. Therefore, choose close timer. Well done, choose axis 0. Make axis 0 move 500 distance. Next, it is time to run it to see effect. We can use our RTSys scope tool to watch the situation clearly. Move axis 0, so choose axis 0. Capture feedback position MPOS. And out 0 signal data. Click Run, it is capturing needed data immediately. See, out 0 is opened when at 50. At 100, invert it, out 0 is closed. At 150, on. At 200, of. PSO is shown. Let's see encoder latch function. Step 1, select latch axis number. Step 2, choose latch modes. Here, mode 3 is used. Step 3, click it to open latch. Click Run. It can be seen it reads the position while outputting. And results are shown here. In this way, through PSO and latch, you could achieve stable and high-speed actions. Okay, today's lesson is over. Thank you for your watching. Any needs, let's connect. See you next time.